So what we're looking at today is writing an augmented matrix. So an augmented matrix is taking our systems of equations or two equations and writing them as a matrix. A matrix is a rectangular arrangement of numbers. The dimensions of the matrix with m rows and m columns are m by n, and it's written by this, like mxn, reads m by n. So the dimensions of matrix A are 2 by 3. The numbers inside the matrix are elements. So it's almost 2 by 3. Our rows and our columns. And you have that down there. So we go down and then over. First number is going down, second number is going over, is our rows and our columns. And each one of these is an element. And whenever we talk about an element, it's normally denoted as a little a, or whatever the matrix is. If the matrix is called A, all the elements are going to be little a, row, column. First number is row, second number is column. So if the matrix is A, we denote it as little a, so row and column. So little a is talking about the element. Capital A would be talking about the matrix itself. And we're going to deal more in matrices, how we can add, multiply, or add, subtract, and use scalars tomorrow, and more in depth of what an actual matrix is. Now, a matrix derived from a system of equations, written in standard form, is the augmented matrix of the system. So, if we have this 3 by 3, this 3 variable system of equation, we can rewrite it as an augmented matrix like this here. Now, one of the things we do have to make sure is that in these 3 equations, all the variables line up. So if x is first, x has to be first in all 3. If we want y in the middle, y has to be in the middle of all 3. And if z, we want it to be last, has to be last. They have to match up. I can't just have them mix up however I want. They have to line up, x's, y's, and z's. And then we rewrite it as this here, and we just take the coefficients. So 5, 3, negative 2, 1, 5, 3, negative 2, 1. Here, 1, 2, 3, negative 1, 1, 2, 3, negative 1. 3, negative 4, 1, 10, 3, negative 4, 1, 10. It's just copying it over from the system to the equation. And that's all we have to do to write an augmented matrix. So this will make more sense as we actually look at it. So when we write an augmented matrix, first things first. First thing, do the variables line up? And here it's no, because here we have y and then negative 2x equals 1. And on bottom we have x plus 3y equals 12. They don't match up. In the first equation, y is first, not x. So I'm going to rewrite it. So I can just switch these two, yes? And do what? Have negative 2x plus y equals 1, yes? I can rewrite the equation. There's nothing wrong with rewriting it. Now do we have x first in both of them? Yes? Okay. So x is first, y is next, and we have equals 1. X, y equals a number. So we're going to do a bracket here. Bracket. So we can put this one on top. So our first coefficient is what? Our next coefficient is 1 and 1. Now it'll use this little dotted line to kind of signify that's where the equal sign is. You won't have to put that always. You can leave it out if you don't want to. Don't want to use it, but that's fine. That's all I have to do here. So let's look at the other equation. We have what? 1, 3, 12. We've written an augmented matrix. That's it. That's all we have to do here. Now the dimensions. How many numbers do we have here? We've got what? 1, 2, yeah? How many do we have here? So this is a what? It's a 2 by 3. That's the dimensions of this matrix here. So any questions on this here? Not too bad? We good with this here? Yes? Let's do another one. So this here, again, they switched the variables around, didn't they? One of them's got yx, the other's got xy. I can switch the top one, it doesn't matter which, because I can do the bottom one or the top one, doesn't matter. Really doesn't. Let's use the top one here. So if I switch this, what we'll have? 4x plus 13. It might be easier for us when we start solving these to have an x, y, z, just so we can kind of keep it straight. So let's write it out. So what would our numbers be here? So 4, 3, 13. So 2, negative 1, 5. So if we take that's fine. I mean, we take the sign with it. Because really, we're taking the positive signs with it, but we don't write plus 4. It's just, we don't do it. It's just not in our mathematical notation. But the minuses we take with it because it's saying it's a negative number. That's the only reason we take them. So we wrote an augmented matrix. Now what are the dimensions? 2 by 3. That's it. Questions on this here? Y'all liking this so far? We good with this one? Okay, just got harder. X, Y, well, hold up. Is this Z on the wrong side? Yes? Because we want the variables all on one side and we need the number without a variable on the other. Which is fine, except for this negative 2Z is on the wrong side. Yes. So I can add 2Z to both sides. This side over here, negative 2Z plus 2Z will cancel. Now, does 2Z have any like terms on this side of the equal sign? No. 3x minus 4y plus 2z equals 7. So this one doesn't have any z, yes? Yeah. Questions? So what number can I put in front of z? So really we have what? Plus 0 z here. So if a variable doesn't show up, it is what? It'll be 0 in the augmented matrix. So we can use this one here as the first one. So what would, or this, let me point at it here. This one as the top row. So would it be what? 2, 7. Let's do this one. So this was top. Let's call this middle. So we have what? 9, 3. Bottom. 2, 4, negative 1, 2. Really easy stuff so far? Yes? What are the dimensions? What are the dimensions of this? 3 by 4. We went down 3 over 4. How many of y'all have dealt with a matrix of some kind in your life? How many of y'all have gotten a candy bar out of a vending machine or used a vending machine of any kind? Guys, again, Chromebooks close, I know. Just, we've used a vending machine at some point, yes? What does it say when we pick the one we want? Like B4, yes? Row B, column They treat it just like a matrix to get to that item in the computer. Are we good with this one here? Yes? Let's look at this one here. X, Y, Z, they all line up, don't they? So I don't have to do anything with it. I don't have to change anything about it. I can just go on and write it. So what do we have? So 8, -3, 1, 5. We're just taking them straight from this row here. And then 2, 2, 1, 4, 2. Then 9, -7, -3, -6. We're just taking the coefficients, the number in front of each of the variables. And then we have another 3 by 4. We liking these here? These aren't too bad. Now, trying to solve these, y'all probably wouldn't be as happy with, correct? No? So I think we're good with these. We'll move on to this here. Now, solving systems of equation using technology. We can use these calculators to solve these here, to find the answer. Because for whatever this system is, we see that x, y, z is -1.4, 5.2, and 6. Well, we've been setting it up as what? X, y, and z, yes? So for this top line, we say that we have x plus 0y plus 0z equal what? -1.4. Well, these here might as well not be there. We're saying x is equal to what? 1.4. The second one would be 0x plus y plus 0z equals, so y equals 5.2, yes? And last but not least, 0x plus 0y plus z equals 16. So really z is equal to 16, yes? So having it lined up x, y, z when they did the matrix is helpful, okay? Yes?
So you're saying x equals that, but it also says that the arguments are stated that x equals 1.
Well, x, the coefficient in front of x is, so we're saying 1x is -1.4. You're good. Now these here are the steps. We write it as an augmented matrix, enter it in the calculator, use row, reduce row epsilon form, and then input our solution. Now, we're going to start off with this here. Now, do we have our 3-variable system of equation in x, y, z? Yes? So let's write the augmented matrix first. So looking at this here, what would our augmented matrix be? So we have, so 1, 1, 1, 2. 2, 3, 2, 3, 1, 3, and negative. Does everybody agree with this augmented matrix? Yes? Now, if you need a little space to write that, I mean, you can write it off to the side. There's lots of space on the sides of your note sheets to write that. Now, after you get that written down, I want you to turn on your calculator. And if it has something other than just pretty much a blank screen. Second, quit. Second, mode. So second, the button next to second.
Second plus 712.
Yep. Yeah, some of them have cleared. Yep, that needs to stay off to the side. So what we're going to do first is I want you to, so our first set of steps for this here is you're going to hit second, and it's not going to say matrix. It'll say matrix in blue above the button. So x to the -1. Button looks like there's not an M. There's x to the -1. Do you have something, I mean, there might be numbers in there, but something that looks like A, B, C, D, E, F going down? Yes? So scroll over to where it says edit. Edit should be darkened on the very top. So second, X. Gotta do that first. So you have to do second x to the negative 1, and you should get this. Scroll over to where edit is highlighted. Do y'all have that? And hit enter, because it should select matrix A. Okay? Now looking at this here, so what were the dimensions of our augmented matrix? It's a 3 by 4. So up there at the very top, we need 3 by 4. We can do 3, enter, 4, enter. We got the dimensions in? We're going in. Type in the augmented matrix into it. So across the top, it should be 1, 1, 1, 2, 2, 3, 1, 3. 1, negative 1, negative 2, negative 6. And when you do the negatives, make sure you do the negative button, not the minus button. And you can hit enter after you put each number in. And it'll just move on to the next one. So you can do 1, enter 1, enter 1, enter 2, enter, and that should be the top row. Once you get every single number plugged in, once you get all the numbers of this matrix plugged in, do second quit. Once you get them all plugged in, do second quit. You got there? Yes? Is anybody, let's see here, there's still a few typing it in. Anybody having any trouble typing this in? Yep, once you get it all typed in, hit second. Careful. Because we want this to be what kind of a 3 by 4. So we'll type the rest of it in. Second, and then the button next to it that is quit. So second mode. Yep. I think almost everybody's got this typed in, yes? Okay. Now once you get that typed in, and you should be back to a blank screen, you shouldn't see the matrix anymore. What you're going to do next, I don't stop going forward. Second matrix. So what we did to call up the matrix this time, but instead of going to edit, scroll once to math. And you should get a list something like where it has a whole bunch of things going down. Yes? Scroll down until you see R, R, E, F. R, R, E, F. So there should be one that says REF. We want RREF. So we want 2 R's. Hit enter. Hit enter. So you should see RREF, yes? But it doesn't have this A, does it? So what you're going to do to get the A is second matrix. So what we did to get the matrix, but instead of going over, just hit enter if you put it in matrix 1. Since we put it in C. So second matrix. So scroll over 1 and go down to R, REF. Keep going. Keep going. Right there. Enter. And then second matrix. And so, okay, so it wasn't 3 by 4. So you need to plug in this augmented matrix. Does everybody have it doing REFA, or whichever matrix you plugged it in? Yes? Hit enter.
Hit enter.
Hit enter.
So I hit it again, and I got one ref up.
Okay. Okay. So once we get this up, we're going to use second matrix. And the one we put it in was A.
Okay.
Questions on this here? Hit enter. And you just hit enter. Hit. Yep. You want to hit enter, Alexi? You can hit enter. So we got something like this here, yes? Or is that what yours looks like? So what this is telling us is that our solution is that's it. That's all we have to do to solve this system of equations. Is it more complicated than doing it by hand? Because what those are saying is that 1x is equal to, so x here, y, z, because these are all zeros. X is -1, y is 1, and z is 2. That's it. All right, guys, so we're going to do this again. We're going to solve another one doing this method here. So the first thing we need to do in solving this is to write our augmented matrix. So across the top we have what? 2, 3, -115, and then 3, 9, 9, -12, and lastly, and this is a 3 by 4. So to type it into the calculator, the first thing we're going to do is second matrix, and then go over to edit. Second matrix, and we go all the way over to edit. Now we should already have on the first one matrix A, if you hit enter on A. It should already say 3 by 4, which we want. Yes, 3 by 4. So then we can go down to the first row and type the first number in. So 2, and then I'd hit enter, because every time you hit enter, it'll move over to the next number. It doesn't like subtraction as a negative. So it's going to want, again, so if it says -1, it's going to actually want -1. You cannot put -1. You have to use the negative. You can't use the minus. It'll throw it out. Because what it's looking for, if you use the minus, it wants a number in front of it. It wants something in front of that number because it's trying to subtract something. So we have to use the negatives. You all have this typed in? Okay, if you're still typing it in, that's fine. Once you get it typed in, do second quit. Huh? So you're back there? You get it typed in? So once you get it typed in again, what did we do? We went second, matrix, scrolled over 1. So math is highlighted, and then scrolled all the way down to RREF. You're going to want 2 R's. And once you put it in, press enter. That looks ugly, doesn't it? That might be why.
I also put it on.
Oh, that would be it too. So 3 by 4, 2, 3, negative 1, 15. 3, negative 9, 9, 12, 4, 3. And that's it. It was just that one number. So what did we get for this year?
5, 1, negative 2.
I calculated that doing the
So did you put it in matrix A? No, that matches. That matches. So you put it in A. Yep. Yeah, something, there's probably a number off. Now, guys, the reason, because once you plug it in, the reason I say second quit after you finish plugging it in is if you try to do second and do the REF, it's going to put it into that matrix. And that's what happens. So you need to make sure you quit out of the matrix before you edit it. Questions on this here? We're good with this here? We kind of see how this works? Yes? You will be allowed to use these on the test. You will be allowed to use these on the test. It will be next week because, yep, we have one last thing, one last section to cover. Questions on this here? Now, if you plug them into the same matrix, did you see how it said REF above it, where we plugged it in the first time? If you scroll up, have you seen how you can highlight it and bring it back down? Yes? Because if you hit the up arrow, select REF where it's there, and hit enter, how it'll bring it back down and I can hit enter again. So if I change matrix A from the previous problem to the new one I want to do, you can scroll back up and bring it back down. So it'll change it for the new matrix. Questions on this here? Are we good with this here?